If you look at insurance losses every year, you will find that hurricanes, which is the North Atlantic version of a tropical cyclone, are the dominant source of losses. And that's been true for the last 30 or 40 years. But now, increasingly, the value is in China. So you have areas like in South China around Hong Kong, which has maybe the GDP now of Florida. And they have maybe 4 typhoons every year. And that used to be a fishing village in Hong Kong, and now it's 50 million people, a huge amount of trade, the world's biggest bridge, huge ports. All of that is new. So now we need to understand the risk of typhoons much more than we did before. There were 3 things we wanted to do in terms of the project. The very first thing was to build this catalogue, so basically establish what has happened in the past. And one of the reasons we needed to do that is when you look at what's happened in the past, it doesn't quite give you enough information for the risk assessment. So what you need to do is you need to take the data to build a statistical model which looks like what happened in the last 50 years, but also allows you to simulate thousands of cyclones. So you can examine also the probability of cyclones that maybe didn't happen at all. So that was the second step, to build a stochastic model. And the real innovation was that the current way of doing these stochastic models is they generate a typhoon somewhere over the ocean, just randomly generated, then they randomly move it across the ocean, and then it makes landfall. And during that track, they also simulate the intensity changes and so forth. And we sidestepped all of this by simply focusing on the landfall, because ultimately that is what matters. It doesn't matter what happens 1,000 kilometers 5 days earlier, it's irrelevant. So we're building a new type of model based on the new catalogue. And then the last part, which we are just about to finish, is that there's some interest in doing what we call a seasonal forecast. So we all know a weather forecast, which is maybe 5 days. A seasonal forecast is not saying that any particular typhoon will happen, but it might tell you that for the entire year, you can expect 5 tropical cyclones. This year, next year you might expect 4, and it is trying to make what we call a seasonal forecast, so a total for the year. So if you are, for example, a city and then you need to be prepared for the emergency, you obviously want the 5-day forecast, but maybe what you also need to do is you need to make sure that the infrastructure is in place. Most importantly, maybe you need to make sure that your budget is in place. So these are all things that you want to plan many, many months in advance. For insurers, they also have actually an insurance contract which needs to be done and delivered very early on. So you imagine you might need a contract signed in January or March, but certainly not in the typhoon season for your insurance product. So you need a good price for the premium and an agreed contract early on. So you really want access to the seasonal information maybe as early as January or even in December for a January contract. And therefore you might want to be interested in knowing whether this year will be particularly a high risk or low risk. And this is the seasonal forecast can help those people make sort of informed decisions. How do we do this? So actually we found a new way of doing it, and what we've discovered is that normally people look at ocean temperatures. So this is one big predictor. So there is something called an El Nino phenomena, which is an oscillation of the Pacific ocean temperature, equatorial Pacific, a long way away from China actually. But it determines, for example, where the cyclones are formed initially, and more importantly, it actually influences the wind circulation in the entire Pacific. So it affects what we call the steering wind. So the steering wind is basically some sort of a mid-level 5-kilometer height wind, which basically pushes the cyclone anywhere where the wind goes. And the cyclone is almost passive. It gets carried along like a vortex in your bathtub, and you just sort of push it along. So the seasonal forecast is really being able to predict this wind. And the El Nino phenomena is an important phenomena. If you can predict that early, then from that you can infer what will happen about the landfall, the probability of landfall. So people have investigated the importance of the phenomena for a long time. So it has been known for a long time. What's new from our point of view is that we've looked at not the sea surface temperature, which is what normally people look at, and because there are satellite observations going back to the 1970s of sea surface temperature. But going back maybe only 15 years, we actually have subsurface oceans. So you actually need to put buoys into the ocean and make measurements in the subsurface. And there we're getting a very strong signal in the subsurface. So we have looked back in the last 20 years, 25 years, And we find that these subsurface temperatures do indeed predict what actually has happened in the last 25 years. So there's what we call a strong correlation. And we find that if that's unusually warm or unusually cold, then we get unusually high or unusually low typhoon counts. And we can do this as early as January if we look at the Pacific Ocean temperature, because it tells us roughly what will happen in the Pacific in the summer by looking at what is happening now in the subsurface ocean temperature. If you imagine that the sub-ocean temperature is like a memory of the ocean, and eventually it is communicated to the surface, and then the ocean surface communicates with the atmosphere, and then that communicates with the typhoons. So there's a chain of heat anomaly which can drive the circulation going back many months before the actual event happens. So I think the glue within the project is what we call the Oasis Hub. So this is the website where we can put all the data. We have our catalog on there, we have our model, our stochastic model I described, and we have the seasonal forecast on that website so that it's free for the users.